Okay, so for this example, we're finding all vertical asymptotes. So with vertical asymptotes, that is going to be a line x equals. Recall the definition. If a line x equals a is a vertical asymptote, that's going to happen if and only if the limit as x approaches a from either side of f of x is equal to either positive or negative infinity. So we have a lot of potential x values that could be vertical asymptotes, an infinite amount, in fact. X equals 1, x equals 2, x equals 17, x equals negative 8. I don't want to have to check every single one of those numbers. So what we do is we come up with a list of potential candidates. If you're going to have a vertical asymptote, your function is not going to exist there. Your function is going to either have a hole, not a hole in the graph, but you would see that it goes up to infinity or down to negative infinity. Well, where can those things happen? Those things happen when the denominator is equal to 0, because we're not allowed to divide by 0. So that's the first thing that I need to look at. When will my denominator equal 0? So x squared minus 16 equals 0 needs to be solved. That's very fast and very easy. There's a couple of ways to do it. Option number 1, you could add 16 to both sides. And then you have to answer the question, what can you square in order to get 16? Technically, you can take the square root of both sides. Remember, when you take the square root of 16, it's only going to be positive 4. But that's not the question you're asking. You're asking, what can I square to equal 16? I can square two different numbers to equal 16. I could square 4. That would equal 16. I could square negative 4. That will equal 16. That's the question that's being asked of you. It's not that you're taking the square root. You are to get that answer. But the square root of 16 is just 4. When you're solving x squared equals 16, you're solving what can I square to equal 16. So we have two potential candidates. We went from an infinite list of numbers down to two possibilities. Those are not guaranteed to be vertical asymptotes. Those are just our possibilities. So now that I have these possibilities, I need to check these to see if they are indeed vertical asymptotes. How do I do that? I go to the definition. X equals 4 is going to be a vertical asymptote if and only if the limit as x approaches 4 from either side, left or right, is equal to positive or negative infinity. So we need to look at the limit. Since I wrote 4 first, I'll go ahead and I'll do 4 first. The limit as x approaches 4 of f of x, of my function. We know how to evaluate limits. To evaluate limits, we simply take that 4 and plug it into the function. And so my function is x squared plus 7x plus 12 over x squared minus 16. So if I plug 4 in there, that'll be 4 squared plus 7 times 4 plus 12 all over 4 squared minus 16. And so when I evaluate that, 4 squared is 16, 7 times 4 is 28, plus 12, if I add that all up, that's going to be 56. In the denominator, 4 squared minus 16, that's going to be 0. So I have 56 over 0. We talked about this earlier. We said that when we take any number that's not 0 and we divide by 0, we can't evaluate that. We don't know what it equals, but we know what it approaches. 56 divided by 0 is going to approach infinity. Any number divided by 0 will approach either positive infinity or negative infinity, depending on whether that number in the numerator is positive or negative. We can't actually do 56 divided by 0. It doesn't work. But if we put smaller and smaller and smaller and smaller and smaller numbers in the denominator, our answer gets bigger and bigger and bigger and bigger and bigger. And so that approaches infinity. That's why I didn't put an equal sign. But that's fine. That's what the limit says. The limit says that when you plug in your x value, when look at the limit as x approaches 4 of your function, if that equals infinity, you have a vertical asymptote. So I know x equals 4 is one of my vertical asymptotes. I may have more. It may be the only one. There's only one other possibility. That's negative 4, because that's the only other x value that we got when we set the denominator equal to 0. So we're going to go ahead and take a look at that limit now. We'll look at the limit as x approaches negative 4. We're going to do the exact same thing that we did for positive 4. We're going to take negative 4 and we're going to plug it into the equation. So if I plug negative 4 into the equation, careful, I have negative 4 squared. That's real easy to make a mistake on your calculator. It does need to be in parentheses. Plus 7 times negative 4 plus 12 all over negative 4 squared minus 16. Okay, so in the numerator, negative 4 squared is 16, plus negative 28 is negative 12, plus 12 is 0. In the denominator, we get 0. So I have 0 divided by 0. Recall, we said any number that's not 0 divided by 0 approaches infinity. When you have 0 over 0, that's when you have to do what we did back in section 2-1. There's an example of something like this on the YouTube channel in one of the other videos, so check that out if you're stuck, if you're struggling. We're going to take a look at what we need to do. So we're still looking at the limit as x approaches negative 4, but I'm going to write the function that I have there instead of just writing f of x. So it's x squared plus 7x plus 12 over x squared minus 16. So when we evaluated these before, we said what we need to do is we need to mess around with the equation. So I'm going to go ahead and I'm going to factor this equation, both numerator and denominator. My numerator will factor into x plus 4 times x plus 3. If that's something you struggle with, you need to come and see me. That shouldn't be something you struggle with. It's Algebra 1. But if it is, come in and see me. We'll clear it all up. Same thing with the denominator. We need to factor that. That's x plus 4 times x minus 4. Realistically, I should have limit in front of that. This thing should be written in front there. That is poor writing on my part, and I apologize. So now we're going to do the evaluation of that. So we cross out our x plus 4s since they reduce down. So now I'm just looking at the limit as x approaches negative 4 of x plus 3 over x minus 4. Now when I plug in my limit, when I plug in negative 4 plus 3 is negative 1. Negative 4 minus 4 is negative 8. We would never leave an answer like that, right? Because two negatives divide to be positive, we get positive 1/8. No matter what, whether we clean that up or don't clean that up, that's not infinity. That's not negative infinity. This limit as x approaches negative 4 is 1/8. Therefore, x equals negative 4 is not a vertical asymptote. So all we have is one vertical asymptote. X equals 4 is a vertical asymptote. It's the only one. There couldn't possibly be any other vertical asymptotes because x equals 4 and x equals negative 4 are the only two numbers that make the denominator equal to 0, and vertical asymptotes are only going to happen at those points. And since x equals 4, the limit is infinity, that's a vertical asymptote. Since x equals negative 4, that limit is 1/8, it's not a vertical asymptote.